In this video of gravitation, you will learn about the relation between acceleration due to gravity and gravitational constant, and the variation of acceleration due to gravity due to height and depth. Consider the Earth to be a sphere of mass capital M and radius r. Suppose a body of mass m is lying on its surface as shown. According to the law of gravitation, the force of attraction between the Earth and body is Gmm upon r square. The force of gravity capital F produces an acceleration small g called acceleration due to gravity in the body of mass m, and therefore from Newton's second law of motion F is equals to mg. On comparing it, you got small g is equals to capital G into m upon r squared, and this gives the acceleration due to gravity on the surface of Earth, and it is independent of the mass, size and shape of the body falling under gravity. Now let's calculate acceleration due to gravity above the surface of Earth. Again, consider a point mass on the surface of Earth as shown and find out the acceleration due to gravity. Just we have calculated in the last slide, and you will get small g is equals to gm upon r square. Now consider the same point mass small m at a height h above the surface of Earth as shown in the figure. The total distance from the center of Earth now will be capital R plus small h, and let gh be the acceleration due to gravity at this height. So mgh will be equals to gmm upon r plus h whole square, and you will get gh is equals to gm upon r plus h whole square as equation number 2. Now divide the equation number 2 by 1, and on solving it, you will get 1 plus h by r whole power minus 2. Now here, because h by r is very less than 1, so you can apply binomial expansion and neglect the high power terms of h by r. Therefore, gh by g will be equals to 1 minus 2h by r, and hence gh will be equals to g into 1 minus 2h by r. From this equation, it is clear that the acceleration due to gravity decreases as altitude of the body from the Earth's surface increases, and the acceleration due to gravity is independent of the mass of the object. Here is a variation of acceleration due to gravity due to depth. Let m be the mass of Earth and r be the radius of Earth, and acceleration due to gravity on the surface, as we have calculated earlier in this video, is g is equals to capital Gm upon r square. Consider the Earth has sphere of uniform density rho, and you know that rho is equals to mass upon volume. So from here, mass is equals to volume into density. And you know the volume of our spherical body is 4 by 3 pi r cube because its radius is r and density is rho. So by putting this value of mass in the density formula, you will get the value of density, and from here you can calculate the value of mass. Now put this value of mass in the acceleration due to gravity formula. Small g is equals to g into 4 by 3 pi r cube into rho upon r square, and on solving it, you will get 4 by 3 pi r rho g. Now consider a point P at the depth d. below the surface of Earth, where the acceleration due to gravity be GA. Distance of point P from the center of Earth is r minus d, and the acceleration due to gravity at point P due to the sphere of radius r minus d is Gd is equals to gm1 upon r minus d whole square. Here m1 represents the mass of inner solid sphere of radius r minus d. On the same basis as we have calculated mass earlier, find out the m1 for remaining radius r minus d, and you will get the value of Gd equals to capital G into 4 by 3 pi r minus d cube into rho upon r minus d square. Divide this equation by G and you will get the value as Gd upon G is equals to 1 minus d by r, or Gd is equals to G into 1 minus d by r. From this expression, it is clear that the acceleration due to gravity decreases with depth. The above consideration shows that the value of G is maximum at the surface of Earth, and it goes on decreasing with increase in depth below the Earth's surface and with increase in the height above the Earth's surface. This graph represents the variation of acceleration due to gravity with depth and altitude. At the center, the value of G is 0 and it increases up to the surface, and from the surface, as the altitude increases, again it decreases. And one main point you have to note that at the center of Earth means small d will be equals to capital R, the value of Gd will be 0. Thus, if the body of mass m is taken to the Earth's center, its weight will become 0, but mass of the body will not be 0.